Welcome back, everybody. Let's finish off lesson 3. We're still working through section 1.3, so you should have this PowerPoint or your written notes or something open and in front of you. With respect to this section, again, I want to point out homework. Hopefully, I can make sure that everyone has access to the textbook one way or another by next week. And you can do some of these questions. I believe that the solutions up until this point have been posted. I'm sure if they're not, I will get an email. Please, one of you, let me know if I have not posted solutions up until this point, and I will rectify that immediately. Other than that, let's get started. This one's only 8 slides as well, so it should be fairly quick. One of the things we want to talk about here is getting fuel from waste. Okay, fuel in a lot of senses is energy from biomass. The gasoline that we burn comes from petroleum oil, which as we talked about in the last lesson, petroleum oil is the dead remains of organisms that died millions of years ago, and they've spent the last few million years or tens of millions of years or hundreds of millions of years beneath the Earth's surface, and we extract them and we burn that. That's biomass. There's energy in those molecules. Okay. Now, landfills are ecosystems that contain organisms. There are raccoons and seagulls, and there are many organisms that you cannot see, including bacteria. Okay. The reason for that is because landfills have a lot of stuff that is organic and can be eaten or consumed. Okay, food scraps, yard waste, some of that stuff is edible to animals. Some of it represents fuel or food for bacteria. Okay, but all around there are these molecules of glucose that can be extracted even once we're done with it. Think about a banana peel. We eat the inside of a banana, okay, and we throw the peel out. But there is stuff inside that banana peel that we don't eat because it doesn't taste very good. But other organisms might find a lot of energy in that banana peel, okay? Now, one of the dangerous things is that inside a landfill, there's often very little oxygen. So yeah, of course, on the surface of the landfill, yeah, you know, you're exposed to the air if the landfill is uncovered, okay? There's a lot of oxygen, but typically what happens is we bury our garbage, we bury our waste, and then we lay over it soil and grass. We actually do this a lot in Hamilton, so not that I want to get too deep into it, but if you do look up some of the things that we do in the city of Hamilton, we've actually turned a lot of landfills into parks and green areas, but underneath where all the waste is, there's not a lot of oxygen because we keep it sealed, okay? And down in there, there's a lot of bacteria, okay? And the bacteria, they're breaking down glucose, but like we talked about last time, they're not using cellular respiration if there's no oxygen. They're using the process called fermentation, okay? And fermentation is releasing energy without oxygen. So we call that anaerobic, okay? Now, energy that bacteria cannot extract gets converted to methane, okay? So one of the waste products that might end up being produced in this process is a gas called methane, which is CH4, okay? Now, methane is something that burns, okay? It is flammable. And so there are landfills in Ontario, and what they do is they install these systems that will pull methane out of the landfill, okay, and collect the gas, and then you can burn that gas and produce electricity, okay? So there are homes in this province. Now in Hamilton, and not really, our energy, our electricity is mostly hydroelectric, but in other places that don't have the luxury of living near Niagara Falls and having the hydroelectric power that we do, they may power homes using this methane gas. Now, How do we feel about burning methane gas? Well, when we burn it, we do produce greenhouse gases. It does contribute to the greenhouse effect. But at the same time, we're also kind of taking advantage of our landfill space. So there's some positives and there are some negatives, and it's more of a complicated discussion as to whether this is worthwhile or whether there are other sources of energy that we can use or should use. But be that as it may, this is something that goes on in Ontario. We are using that methane in places in Ontario and around the world to use in power generation. Okay, so basically that means the waste gets consumed by the bacteria. The bacteria excretes methane as a waste product. That methane is collected and then through pipes taken to power plants, burned, and then it produces electricity, which makes its way to people's homes. Okay. We can talk about costs and benefits to that. Is it good for the environment? Maybe, maybe not. Is it good that we're taking advantage of that space that would otherwise lay empty and full of garbage? It's debatable. Okay. Now, here's a downside. Acid precipitation. When we burn fossil fuels, okay, like gasoline, two of the waste products, two of the products are nitrogen oxide and sulfur dioxide. They're gases, they're colorless, okay, and they're released into the atmosphere. And the problem is in the atmosphere, in clouds, they combine with water and they produce nitric acid and sulfuric acid. Now, acids aren't something that we've really studied yet in terms of chemistry. We begin to study acids in grade 10. And then we do a lot of work with acids from grade 10 to 12. A lot of work actually in grade 10, 11, and 12. Acids play a big part. We haven't really learned about their properties yet, but I think that based on what we kind of see in the media or from movies and TV shows, we know that acids can burn, okay? Acids react and they corrode different substances, okay? So now what you have to think about is that precipitation falls, it's rain, it's snow, it's fog. Okay, we know what precipitation is, we know what rain, snow, and fog are, but what if that rain, snow, or fog was acidic? What if it was acidic chemicals that were raining down? And that does happen. That is a real thing. Okay, and you can see in the diagram here on this slide, on this page, we see the sulfur dioxide and the nitrogen oxide produced. Okay, we see it reach the clouds, we see it combine with water, and we see it form those acids, and then we see the acid fall as acid rain or acid snow. Okay, not a good thing. So just a quick aside, because again, we're going to learn this in the chemistry portion of grade 10 science. Okay, but you kind of need to know it now so you need to understand a cursory, you have to have a cursory understanding of acidity. The way we measure acidity is we actually use something called the pH scale. And what the pH scale does is it identifies substances that are either acidic, basic, or neutral. So what we would say is water, pure water, has a pH of 7, it's neutral. Okay. If you have a substance that goes above 7 on the pH scale, you're going to get a basic substance. Okay. And an example of that is ammonia. And ammonia is something that we use as a cleaner. It's a cleaning product. Okay. Baking soda is another base. Typically, we find a lot of cleaning products that are on the basic side of things. Now, you don't need to know the properties of bases, but they are also corrosive. You get bases on your skin, and if they're high enough in concentration, in other words, if the pH is high enough, they can damage your skin, they can corrode things. We need to worry about pHs that are below 7 right now, because below 7, we find acids, okay? Now, when things are slightly acidic or slightly basic, that's okay, okay? That's okay. We eat acids when we have vinegar or when we eat citrus fruits. Okay, oranges are acidic, slightly. Okay, orange juice, slightly acidic, and typically rainwater can be slightly acidic. Okay, but at a pH of around 5.6, it's acidic, but it's not acidic to the point of being dangerous or harmful. When pollution exists, when we're burning those fossil fuels and we're releasing those sulfur dioxide and nitrous oxide, nitrogen oxide chemicals, particles into the air, into the atmosphere, and we're forming sulfuric acid and other acids, we can reduce the pH of the rain to as low as 4.2 or even maybe lower. Now, when we reduce pH, that actually means we become more acidic. And the more acidic something is, the more likely it is to corrode or cause damage. At low enough pHs, organisms will die. So if you look at this diagram here, it actually shows the pH scale. And there's a certain section there in between pH of 4 and pH of 3. It says adult fish die. So what we can see there is one of the effects of acid rain. If the pH hits 4.2, and it can, and it does quite often, then aquatic life can actually suffer, can actually die, and that's quite bad. That's quite dangerous. Okay, that really does throw off the natural ecosystem, and we definitely don't want that. Okay. So there's a couple things that can happen because of precipitation. Okay. On a terrestrial ecosystem, that is things that are living on land, okay, acid rain can cause forest soil to lose nutrients such as calcium that do not dissolve in water, but do dissolve and wash away in acid. So you know that we as human beings need to ingest a small amount of calcium in our diets. Okay, you don't need a huge amount of calcium, but you need it. It's one of the many micronutrients that we need in our diets. Plants do too, okay? Animals do too. And usually calcium is found in the soil, and it makes its way into plants, and then animals eat the plants, and so they get calcium, and the plants get calcium, and everybody has calcium. Rain, regular water rain, does not dissolve calcium. However, the acid rain will dissolve calcium, so we kind of leach away the calcium in soil with acid rain, and that can affect the entire food chain, right? In addition, acid rain can increase aluminum in soil. So aluminum is a metal, and aluminum will interfere with the uptake of nutrients by trees. So that, in other words, it is preventing trees. Aluminum in soil will prevent trees from taking in the nutrients that they need. So you can see how we disrupt the food chain there too. If the plants can't uptake nutrients, then the animals that eat the plants, they don't get nutrients, and then we have a problem. Okay. In aquatic ecosystems in the water, if we lower the pH too much, that'll just simply kill aquatic animals and plants. Okay. And those animals and plants that don't die because of the acid rain, well, they probably eat the animals and plants that did die. And so those larger animals that might remain unaffected by the acid itself, well, they're affected because we cut off their food supply. They can't eat, they go hungry. Okay, so just this process of acid rain, even going from pH 5.6 to 4.2 can throw off food chains on terrestrial ecosystems and in the water. Okay. So what this is the tolerance of different organisms to various pH levels. So if we see frogs seem to be tolerant up to pH 4.0. Okay, trout, however, are a little less tolerant. They're only tolerant up to pH 5.0. Look at snails and clams. They're only tolerant up to pH 6. Okay, that's very intolerant of acids, and so a little bit of acid rain can demolish snail or clam populations. Okay, and that's problematic because things eat snails and clams, and the things that eat the snails and clams, they don't get to survive either. Okay, so different animals react different ways to acidity. Okay, but even if an animal is unaffected by the acid, it's affected because the food that it eats may be affected. Okay, so move on from there. What can we do to reduce acid precipitation? Well, there are laws in the US and Canada that are meant to reduce the emissions of nitrogen oxide and sulfur dioxide, okay? And that is in terms of industry, factories emitting these chemicals, and it's also in terms of cars, okay, emitting these gases. So there are certain devices, we call them scrubbers, and what they do is they kind of filter out the gases leaving a factory, okay, and the idea is that they scrub out any unwanted nitrogen oxide and sulfur dioxide that would normally have escaped, and we prevent that from reaching the outer ecosystem, the outer environment. In Ontario, we have the Drive Clean program. And what that means is after a certain period of time of owning your car, you have to get it Drive Clean tested. You have to go get it emissions tested. And maybe you've heard your parents talk about having to take their cars to get emissions tested. You have to go to a mechanic, they hook it up to a special machine, and then they approve you, or they tell you that you cannot drive that car anymore. Okay, and that ensures that they're basically testing whether the car is emitting an appropriate level of nitrogen oxide or sulfur dioxide. And if you look at this graph on the side compares the amount of sulfur dioxide and the amount of nitrogen oxides emitted by cars in Ontario to cars in the rest of Canada. What we notice is in Ontario, we do a pretty good job because we've reduced the amount of these gases that are released when we compare to the other provinces. Okay, so this is a pretty good process, even though it can be a bit of a pain in the neck and a little bit expensive to get your car tested. What it does is it puts pressure on people to make sure that their automobiles are not polluting, okay? Because if your car is emitting to a high enough concentration of these gases, you can't drive it. The Ontario government will not allow you to drive it. Okay, so that's actually a positive thing that the government has done and has done for a long, long time to ensure that every single person is doing what they can to not pollute and to diminish the acid rain in our environment. Okay, so that is the end of our third lesson. It was in 2 parts. So if you're watching this one first, you should have probably gone back and watched the part 1 video that goes with the first PowerPoint slide of lesson 3. At this point, we should be caught up on everything we needed to do for that practice quiz. Now, I know some of you have already written it. What I've actually done is I've extended the date for that quiz. So that quiz will actually be open till I believe the end of day Monday. So Monday at 11:30 p.m. So if you haven't written that quiz yet, and it's not for marks, it's just a practice, you can go ahead and try it or retry it if you like, and redo that quiz. Try it again and again until you sort of understand everything as best that you can. And I will try to get that marked, and you can view your grades next week after that quiz is done. But you should have everything you need if you haven't tried it already. And other than that, I think you should be on the lookout for a little bit more content. We're going to go into lesson 4 probably come Monday, and then hopefully by Tuesday or Wednesday we can get ourselves organized to have a question and answer live stream using some sort of format. I haven't decided what format yet. I put up a Google form as a survey to have people write in what format they prefer me to use. I think last time I checked, 16 people had responded to that survey. And I believe YouTube live stream was in the lead in terms of the format that you guys preferred. And that way I can live stream it and I can record it. And then if you couldn't make the live stream, you can check the recording after. But if you do want to have some input, please head on to the front page in the announcements. You'll find the link there, and you can vote on what format you'd like to do the live stream in, and you can get your questions ready if you do have any questions. And then come Monday, we should have some new content. Should be lesson 4 posted, and we'll take it from there. As we do everything, we're staying fluid and we're taking things day by day at this point in time. So I just want to make sure I remind everyone to stay healthy, stay safe, and just keep learning. And again, if you have any concerns outside of just the curriculum content here, myself and your other teachers and educators and VPs, we're here to support you in any way we can right now. These are unprecedented times, so please make sure if you need anything that you do get in contact with us. We are more than happy to help you. I am more than happy to help you in any way that I can. Okay, until next time, stay healthy, stay safe. Take care, guys. Bye-bye.